Welcome to Summarize Science, where we break down cutting-edge research for you. Have you ever wondered how we teach robots to perform complex tasks, like those in a factory or even one day in our homes? Scientists often use a method where robots learn by watching human demonstrations, which is great for learning complex and creative ways to solve a problem. But there's been a big dilemma. The methods that allow for creativity and learning multiple solutions are often very slow, taking many small steps to figure out what to do next. On the other hand, the faster methods that can react in real time tend to be rigid, often collapsing all the creative solutions into just one repetitive action. This means robots have been stuck in a trade-off: be creative and diverse, or be fast and efficient, but not both. Well, a new paper proposes a brilliant solution called the Hybrid Consistency Policy, or HCP, that gets the best of both worlds. Think of it like this. The robot starts by brainstorming for a very short period, using the slow, creative process to come up with several possible ways to approach the task. This initial phase allows different branches of solutions to form, just like considering multiple paths to a destination. Then, at just the right moment, it switches gears. Instead of continuing with tiny steps, it takes one giant, decisive leap to the final action. This one-step jump is super fast, making the robot highly responsive. The key innovation is figuring out the perfect time to switch from brainstorming to execution. The researchers developed criteria to find this sweet spot, where the different solutions are stable, but the process hasn't gotten bogged down yet. Let's look at the results on a real robot. In tasks like pushing this T-shaped block or avoiding obstacles, the HCP-powered robot successfully learned multiple ways to complete its goal. This demonstrates that it didn't lose the creativity of the slower methods. Now for the speed. Compared to the purely creative but slow approach, HCP was dramatically faster. In some real-world tasks, it reduced the time to decide on an action from over half a second to just 0.17 seconds. That's a massive 68% reduction in latency, which is crucial for robots that need to interact with a dynamic world. Their experiments also showed that if the robot jumps to a conclusion too early, before the ideas have formed, it often fails or loses its creativity. This confirms that the timing of that hybrid switch is absolutely critical. So, to recap the important points, researchers faced a trade-off in robot learning between diversity and speed. Their solution, the Hybrid Consistency Policy, combines a short, creative brainstorming phase with a single, ultra-fast execution step. The result is a robot policy that is almost as creative and successful as the best slow methods, but significantly faster and more practical for real-world use. This work effectively decouples creativity from speed, paving the way for more responsive and intelligent robots. Imagine future robots in manufacturing or as home assistants that can quickly and flexibly adapt to new situations, solving problems in ways we might not have even thought of. This is a significant step toward making that future a reality. Thanks for watching Summarize Science.